Hi guys, my name's Reid, and today's topic, web performance. Today we're going to talk about performance and reliability and how you can incorporate this into your setup. To start off with, we're currently running a WordPress server on a single processor 2TB machine running Apache on Ubuntu. We're currently seeing average load times of around 2 to 2.5 seconds, and we're able to see the inconsistency within the load times after running a few tests. The first thing we're going to try and do is add gzip compression to Apache to see what sort of improvements we get. I'm hoping to see more consistent load times. Gzip compression is a form of compressing files for faster network transfers. Compression allows your web server to provide smaller file sizes, thus improving download times for your users. Firstly, I'm going to go into my htaccess file on my Apache server and add the gzip compression commands, which are available below. Now that I've done that, I'm going to go ahead and reboot Apache to allow the settings to take effect. As you can see now, compression is enabled, so I'm going to go ahead and run some quick performance tests. You can already see vast improvements in load time consistency and in page size. Our page load time average has now dropped by over a second. Another tool that I use often is Varnish. Varnish is an HTTP caching software that caches your pages and delivers the cached version to your users. This stops your server from having to make the same request over and over again for the same page. This software sits in the port of your choice and when required pulls data from your web server. It then recaches the page and delivers the data to your user. I'm going to be setting Varnish to port 80 so that by default all our users will pass through it. Firstly, I'm going to install Varnish by typing sudo apt-get install varnish. This is going to load the Varnish configuration files onto my server. Now that I've done that, we have to move Apache off port 80. To do this, I'm going to head to my Apache configuration files and adjust the ports there. I'm going to move Apache to port 8080, but you can move yours to wherever you like. The two files I'll need to update is ports.config and 000-default.config. These files are located in your Apache configuration folder. Now we need to tell Varnish where to pull its data from when no cache is found. To do this, we're going to head to the Varnish configuration folder, which is located in the etc directory. There, we'll need to open default.vcl. Located a few lines from the top, you should see a backend default tag, and in there, a port and a host value. We need to change that port value to 8080. Now that we've done that, we can go ahead and exit that file and restart Varnish. You can reset services by typing service, followed by the service name, then restart. For instance, I'm going to type service Varnish restart. Let's jump over to our browser to see if Varnish is correctly set up with Apache. You should now see the same page on port 80 and 8080. As you can see now, Varnish has been successfully moved and is running as it should. You can see this by opening up your HTTP headers, and there you should see Apache 2 via Varnish 1.1. There are some handy extensions for Chrome that can help you do this. Now that everything's running as it should, I'm going to run some performance tests. I'm hoping Varnish will improve load time consistency as well as load time. After running the test, we can see our average load time has dropped by half a second, and we're able to see more consistent results. We can already see a 1.6 second improvement in load times, which is great. However, I want to see if we can do any better. The next tool I'm going to implement is called NGINX. Well, NGINX performs exceptionally well in dealing with static content such as HTML, images and style sheets, and in general performs a lot stabler than Apache. What we're going to do is we're going to install NGINX in front of Apache to deal with our static content. Whenever a request is made for a PHP file, we're going to send that request off to Apache for handling. Apache is then going to send back a compressed version of the data and we'll forward that off to Varnish. The first thing we need to do is install NGINX. We can do this by simply typing sudo apt-get install NGINX. Before we start the service, we need to change the running port. To do this, we'll head to the Sites Available folder located in the NGINX configuration directory. There, we'll open a file named default by running nano default in the command line. Here we can scroll down to the server tags, and where it says listen, we can change those two values to 8000. We've now told NGINX we'd like it to run on port 8000. After that, we need to change our root directory to var/www/html. We're going to do this to tell NGINX where to grab its content from. Below that there should be a line telling NGINX what files to look for where no file is specified. These are our index files. We now need to add index.php into there. For NGINX to pass on the PHP files to Apache, it first needs to know how to find them. Now that it knows how to find the files, we need to tell it what to do with them. Below I'll go into a little detail about that, but for now you can just copy and paste the code below into that file there. You should also make sure that the other PHP commands are commented out, otherwise this can cause confusion. Now that we're reading static files and passing PHP files to Apache, we now need to tell Varnish to send all traffic via NGINX. To do this, we now need to go back into our Varnish configuration file and change the backend port to 8000. We can now restart Varnish in NGINX and head over to our browser. We should now see the same page on port 80, 8080 and 8000. Now when someone loads your website and makes a call to Varnish, which will quickly load a cached version. If Varnish can't find a cached version, it makes a call to NGINX, which will quickly grab the file and send it to Varnish. However, if NGINX sees the file as a PHP file, it will send the request to Apache. Apache will then send the compressed data back to NGINX, who will send it back to Varnish. However, if someone was to make a request for an image file or a style sheet, then Apache won't be involved, and therefore the file won't be compressed. So now what we need to do is tell NGINX to compress all its files. We can do this by heading to the nginx.config file. This is located in the NGINX configuration folder. There we can scroll down to the gzip compression settings and uncomment those lines. After saving and exiting that file, we can now restart NGINX. We can now see a small improvement in load times and again more consistent results. So now you know 3 different ways to improve performance and reliability on your site and how you can bring those 3 things together to make one speedy page. That's all for today. My name's Reed. Thanks for watching.